Hello students, I am Chandrapal Sidhabi, Assistant Professor in Department of Mechanical Engineering, Silver Rock University. In previous lecture, we learned about Introduction to CAM, concept of seam, and Introduction to NC and CNC Machine Tools. In this lecture, we will further see about NC and CNC Machine Tools. So, first of all, types of CNC control systems. It is classified in two: open loop control system and closed loop control system. Open loop control system and closed loop control systems are mainly classified on the basis of feedback devices the particular machine has. If the machine has dedicated feedback devices, it is known as closed loop control system. But the machine does not consist of dedicated feedback devices, then it is called open loop control system. Open loop control system. In open loop control system, step motors are used. Step motors are driven by electric pulses. Every pulse rotates the motor spindle through a certain amount. By counting the pulses, the amount of motion can be controlled. No feedback signal for error correction. Lower positioning accuracy. So, the open loop control system do not have a feedback mechanism. The open loop machine tool controls have only motion control but do not have any provision for a feedback, which need to be compared with the input for a better control and correction of drive system. So, if we are giving instruction to the machine that the table should be moved 0 to 5 mm, but we are not getting any feedback that machine table is actually moved from 0 to 5 mm or not. It is called open loop control system. There is no feedback devices in this type of control system. Closed loop control systems. Closed loop control system have dedicated feedback devices in machine. In closed loop control system, DC or AC motors are used. Position transducer are used to generate position feedback signals for error correction. Better accuracy can be achieved in this type of system. This kind of system are more expensive, suitable for large size machine tools. The closed loop control system have a feedback mechanism. The closed loop machine tool controls have a motion control with a provision of feedback, which can be used for accurately controlling the drive system by comparing it with the input information until the required or desired position is achieved. In most of the cases, the feedback is measured by the monitoring devices determining the drive displacement. Various sensors are used to measure particular quantity and give signals to the MCU to compare it and take required corrections. For different types of control, different types of feedback devices are used. Here desired path is shown. 3-axis position control. For 3-axis position control, encoder feedback is used. Velocity control, tachometer feedback is used, and for torque control, current feedback is used. Path generator, linear interpolation, circular interpolation, complex path interpolation, which is countering. Drive systems. A drive system consists of amplifier circuits, stepping motors or servo motors, and ball lead screws. The MCU feeds control signals, which is position and speed of each axis, to the amplifier circuits. The control signals are augmented to actuate stepping motors, which in turn rotate the ball lead screws to position the machine table. Drive system is required for the motion of all the elements. Stepping motors. Stepping motors are important element of drive system. A stepping motor provides open loop digital control of the position of a workpiece. in a numerical control machine. The drive unit receives a direction input clockwise or counterclockwise and pulse inputs. For each pulse it receives, the drive unit manipulates the motor voltage and current, causing the motor shaft to rotate by fixed angle one step. The lead screw converts the rotatory motion of motor shaft into linear motion of the workpiece. Here it is a schematic diagram of stepping. So first of all, pulse inputs are and direction inputs are coming from the MCU to the drive unit. Drive unit further send it to the stepping motor. Here stepping motor for each pulse rotates its shaft and the shaft finally rotates the lead screw which is joined to the shaft. Now on this lead screw machine table is arranged and on this machine table workpiece is fixed. So as the stepping motor rotates, lead screw will get motion, and due to the motion of lead screw the machine table will move longitudinally or as per the instructions. This is how stepping motor works. Recirculating ball screws. Recirculating ball screws are one of the important elements in drive system. It transforms rotational motion of motor into translation motion of the nut attached to the machine table. Here is the diagram of recirculating ball screws. The recirculating types of ball screw are widely used in ANSYS CNC machines where rotary motion of motor is converted to linear motion using lead screws. These are specifically required in slideways. In such system, the balls are in continuous circulation between nut and screw during the complete motion of slide. The balls provides rolling friction and hence have a low coefficient of friction, which gives more than 90% efficiency in position control of slides, which is very high when compared with the sliding friction type lead screw, which is conventional one. In addition, this recirculating ball screw system can be preloaded. This helps in reducing backlash in two-directional motion of slides attached to the lead screws. Accuracy of CNC machines depends on their rigid construction, care in manufacturing, and the use of ball screws to almost eliminate slope in the screws used to move portion of the machine. Component of recirculating ball screw. Recirculating ball screw consists of ball screws, ball nut, vase, and linear bearings. Here it is the picture of original recirculating ball screws. Here, these are the advantages of recirculating ball screw over other elements which is used in CNC machines. So, these are inexpensive, low power usage, low maintenance, high accuracy, high repeatability, high efficiency, high load capacity, and compact size. Whereas these other elements lack some of these properties, but ball screws have these all properties and hence it is most important elements in the drive system. Positioning. The positioning resolution of a ball screw drive mechanism is directly proportional to the smallest angle that the motor can turn. The smallest angle is controlled by the motor step size. Micro steps can be used to discrete the motor step size. CNC machines typically have a resolution of 0.0025 mm or even better. Machine tool. Machine tool. CNC controls are used to control various types of machine tools. Regardless of which type of machine tool is controlled, it has always a slide table and spindle to control of position and speed. speed, which is common in all the machines. The machine table is controlled in the X and Y axis while spindle runs along the Z axis. So, in whichever axis the spindle is operating, then we will consider it as a Z axis. Feedback system. The feedback system is also referred to as a measuring system. It uses position and speeds transducer to continuously monitor the position at which the cutting tool is located at any particular time. The MCU uses the difference between reference signals and feedback signals to generate the control signals for correcting position and speed errors. So, feedback system basically compare the input signal and output signal which has been performed by the machine. If there is any deviation between them, then feedback system will correct it on the system. CNC machines feedback devices. There are number of feedback devices which is used in CNC machines. We will see it. Encoders, a device used to convert linear or rotational position information into an electric output signal. Encoders. Types of encoders: magnetic LVDT, capacitive, contacting, and optical. Generally, optical encoders are used in CNC machines like rotary encoders and linear encoders. Here we can see the picture of rotary encoders and linear encoders. Both are widely used in robotics and industries. The optical rotary incremental encoder consists of glass discs with accurately each lines at equal regular intervals on the outer periphery of the disc. The disc is connected to the lead screw either directly or through precision gearing or time belt. The disc rotates between light source and photodiode. Each line makes or breaks the photoelectric beam and a pulse signal generated is magnified to give a square wave output. A rotary encoder with 360 line can give 360 pulses per revolution, and if a lead screw with 3.6 mm pitch is connected to such encoder, it will give 1 pulse for every 0.01 mm linear movement of slide. The linear encoders are connected partly to machine structure or guide and partly to the slide which moves over stationary guideways. The principle of operation of linear incremental encoder is nearly same as that of the rotary encoder. Here instead of these, glass scales with the line grating are used which have line graduations. The relative movement between the glass scale fixed to the slide and photoelectric sensing device fixed to the guide results in alternate light pulses which generate an electric pulses. The periodic signals are processed and converted into equivalent linear movements. Resolvers. A resolver is a rotary transformer that produces an output signal that is function of the rotor position. It will work and it depends on the rotor position. Servo motor with resolver. Here we can see a servo motor with a resolver system. Here, resolver is attached to servo motor for the position feedback. Drive motors are there to give motion to the drive system of the machine tool. Different types of drive motors are used, which is as follow: DC servo motors, AC servo motors, stepper motors, or hydraulic motors. According to the application, any of these motors are used in CNC machines. Position feedback. For position feedback, these devices are used, which is incremental encoder, quadrature, absolute encoder, resolver, tachometer, etc. Potentiometers are used for position feedback. A potentiometer is a type of position sensor. They are used to measure displacement in any direction. Linear potentiometers linearly measures displacement and rotary potentiometer measures rotary displacement. The mechanical construction of rotary and linear potentiometer is very similar. Each type consists of contact wiper and conductive element, or we can say track. In linear potentiometer, the track is straight, while in a rotary potentiometer, the track is circular. The wiper moves along the track to measure the displacement through proportionally driving the input voltage. Here we can see different size and different types of potentiometers. Velocity feedback. Tachometers are used for the velocity feedback. A tachometer is an instrument which measures the rotational speed of a shaft or a disc. It is designed to measure the revolution per minute (rpm) of moving object. In tachometers, electrical output is proportional to the rate of angular rotation. Now, CNC machines, cutting tools. We can say cutters. CNC cutters, turning center cutters and machining center cutters. Turning center cutters are generally single point cutting tools and machining center cutters are generally multi-point cutting tools. In turning center cutters, cutting tool consists of only one cutting edge, and in machining center cutters, machine tool have more than one cutting edges. Various types of cutters used on CNC centers like carbide insert turning and boring tools, ceramics, high-speed steel drills and steps. In a cutter, various inserts are used. The shape of generally used inserts are as below. V. It is used for profiling. It is known as weakest inserts, 2 edges per side. D. Somewhat stronger, used for profiling when the angle allows it, 2 edges per side. T. Triangle, commonly used for turning because it has 3 edges per side. C. Popular insert, because the same holder can be used for turning and facing, 2 edges per side. W. Newest shape, can turn and face like the C but 3 edges per side. S. Very strong but mostly used for chamfering because it won't cut a square shoulder. 4 edges per side. R. Round, strongest insert but at least commonly used. Threading and parting tools. Till now we have seen cutting tools. Now we will see threading and parting tools. Threading tools are used to develop threads on the shaft and parting tools are used to part of the shaft. It means we can cut shaft in predefined measurement using parting tools. We can say these all tools are single point cutting tools. Machining center cutting tools. Machining center cutting tools are generally multi-point cutting tools which has more than one cutting edges and each one of them acts as a single point cutting tool while it is in operation. Most machining centers use the some form of high-speed steels or carbide inserts and mill as the basic cutting tool. Insert and mills cut many times faster than high-speed steels, but the high-speed steel and mills leave a better finish when side cutting. Here these are the face mill cutters. So face mill flattens the large surface quickly and with an excellent finish. Notice the engine block being finished in one pass with large cutter, which is in background picture. Here ball end mills are used for variety of profiling operations such as the mold shown in the picture. Slitting and side cutters are used when the deep narrow slots must be cut. Here these are some another tools which are used as machining center cutting tools, which is drills, taps and reamers. Common high-speed steel tools such as drills, taps and reamers are commonly used on CNC machining centers. Note that a spot drill is used instead of a center drill. Also, spiral point or gun taps are used for through holes and spiral flute for blind holes. Rarely are hand taps used on machining center. Till now we have seen different types of cutting tools. Now we will see tool holders. Tool holders are one of the important elements in the CNC machine tools. All cutting tools must be held in a holder that fits in the spindle. This includes end mill holders as shown in figure, collet holders, face millet adapters, etc. Types of automatic tool changer. When we are mass producing using CNC machine tools, the workpiece needed to undergo various processes and operation with the help of tools. To provide access of the all tools in one go, the automatic tool changers is needed. So there are types of automatic tool changers. First one is tool changing mechanisms on turning centers, which are turret head types. Another one is drum type tool storage. ATC increases the machine tool's productive time. It significantly reduces the time for changing worn out tools. It provides storage of the cutting tools which are returned automatically to the machine tool after carrying out the required operations. New cutting tools are automatically delivered to the machine by the tool changing system. The rotating magazine holder can provide a tool storage capacities ranging from 60 to 40 cutting units with up to 24 different types of tool geometries. Cutting units can be stored in either a drum or disk type of storage device. A typical example of the storage facility and their automatic tool changers. The rotary tool changers bevel between the tool magazine and the machine's turret. Each gripper can rotate through 90 degrees to deliver tools to the front face of the turret. The tool changer simultaneously removes the cutting tool from the disc magazine and the turret, then it rotates through 180 degrees. The new tool is delivered to the turret and accurately positioned in the correct orientation, whilst the used tool is replaced in its correct turret position. For the reuse or replacement, the tool changer arm is withdrawn from the working area of the machine and start the cutting cycle. Characteristics of ATC. Magazine should be capable of storing required numbers of tools to carry out all the operation on a machining center. It should be compact and simple to reduce its cost and space requirement. It should not be protecting the working space of the machine for preventing it from disturbing tool space at the time of tool changing. It should allow manual transfer of the tool easily and safely at the time of loading and unloading the tools. Here we can see the actual setup of automatic tool changer. This is how the different types of tools are set up in ATC. This is how the automatic tool changer mechanism works. Advantages of automatic tool changer. Low skill requirement. CNC machine operators require little training and skill when compared to the manual machine operators. Capability. This technology uses computer precision to go beyond the limitation of manual capabilities. More complex and intricate operations are possible with CNC machining. Continuous use. Unlike manual labor, CNC machineries bearing any malfunctions or maintenance used can work continuously over any period of time without a break. This greatly increases productivity and efficiency. consistency and precision. With computer software, the design of any given product only need to be programmed once. The CNC machine can be perfectly replicate that design for any order quantity. Disadvantages of automatic tool changer. Cost. CNC machines are more expensive and require a greater initial investment than machines that can be operated manually. However, as this technology becomes the standard, supply is increasing, resulting in cost gradually decreasing. Skill loss. As the demand for manual machine operators decreases, fewer and fewer new students adopt those skills. This could eventually lead to the complete loss of long preserved skills. Unemployment. Automation decreases the need for manpower and fewer laborers are hired. That said, the need is now shifting to software engineers and mechanical engineers, and education and training will have to adjust to meet the new needs. Axis designation conventions. On CNC machine tools, different types of nomenclatures are given for the axis. So, for the main axis, the conventions are X, Y and Z. For rotational axis, the nomenclatures are A, B and C. For secondary linear axis, the nomenclatures are U, V and W. And for incremental dimensions in circular interpolation, it is I, J and K. Here in this figure, we can see X, Z, U and W sign conventions. Further, we will see it in detail. Axis designation for each type of machine tool is suggested in the EIA standard. EIA means Electronic Industries Association standard. This also conforms to ISO recommendation R841. So these are the ways by which we can designate the main axis. So for the main axis, a right hand thumb rule is used. The nomenclature of three main axes X, Y and Z is based on the right hand rule, involving the middle finger, index finger and the thumb of the right hand as shown in the figure. The thumb indicates the orientation of X axis, the index finger indicates Y axis and the middle finger points in the direction of Z axis. So, by preparing the gesture of hand which is shown in figure, we can designate the main axis on the CNC machine tools. Designation of each rotational axis is based on the linear axis about which the rotation occurs. A axis is a rotation about X axis and B is rotation about Y axis and C is rotation about Z axis. When looking along a main axis in positive direction, clockwise rotation is positive. Secondary linear axis U, V and W. So the U is parallel to the X axis, V is parallel to the Y axis and W is parallel to Z axis. Incremental dimensions in circular interpolations, which is I, J and K. So how we designate I, J and K? Beside this designation, I is used as incremental dimension in x-axis during circular interpolation. J is used as incremental dimension in y-axis during circular interpolation and K is used as incremental dimension in z-axis during the circular interpolation. So this is the thumb rule for axis identification which we have discussed before. So here it is in details as we have discussed before for A, B and C axis. Same for X, Y and Z axis. So here we can see the demonstration of axis on the 2-axis CNC lathe. So the spindle axis is the Z axis and the table axis is the x-axis. Here we can see 3-axis lathe machine. The spindle axis is z-axis, the traverse axis of the table is x-axis, and the longitudinal axis of the table is y-axis. 0 points and reference points. These are the points which is used for the reference of CNC machine tools for programming. So, first of all we have machine 0 point, work part 0 point, reference point, tool reference point, tool setup point, tool shank point, and tool change point. Here we can see how different types of reference points are used on machine for programming. Here we can see 0 points and reference points for the lathe. This is how the 0 point and reference points are used on lathe to generate part programming. So it was all for today's lecture. Thank you.